Hi everyone, in today's video we are going over a tutorial on how to use Python and Pandas for data cleaning. So let's get right into it. Alright, so here we are in our Jupyter notebook. The first thing we want to do is import pandas as PD. So we'll do that and run it. Alright, and now the next thing we want to do is read in our data set. So for today's video, we're using a hotel bookings data set. And that data set shows like different information about hotel reservations. And once we read it in, let's go ahead and take a look at the first few rows just so we know kind of what steps we might have to take for data cleaning. All right, so now that we've read in the data set here, we can kind of look through it and see some of the steps we'll need to perform. So here we can see that we have this unnamed 0 column and it looks like it's just a duplication of the index. So that's probably a column we can drop. We can see here arrival date is the month and the year of the arrival date, so that might be something we need to split into separate columns. We can also see there's a lot of NaNs in the company and in the agent column, so that's something that we'll have to deal with. And we may need to rename some of these columns to more accurately represent what the column it contains. We can also see in the hotel column that there's some like special characters in the hotel name, so that's something we'll have to clean up as well. Now this data set, I got it off of Kaggle and I'll link it down below. The data set originally had some messiness already in it that needed to be cleaned up, but I went in and I added some more messiness into the data set so that there would be more cleaning steps for the video. So you can find the dataset on Kaggle online, but you will see it's a little bit cleaner than the dataset I'm using in this video because I did alter it a little bit. So as our first cleaning step, let's go through and see which columns we need to drop or rename. So to do that, let's first print out all of the column names. So we can do that using the columns attribute. So here we can see unnamed 0, that's one we need to drop, and then we'll look through these and see if there's anything we need to rename. So I think the main one I'm seeing we need to rename here is adults, children, and babies. I think that's the number of each one that's there on the hotel booking, so we can probably change that to like number adults, number children, number babies. So first we will drop the unnamed column since we're not really getting any extra information from that, and it's just a duplication of the index column. So to do that, we can use pandas drop function, and we will specify the columns, which we can just copy from up here. And this function also has a parameter called inPlace, which we want to set to true. And that inPlace parameter will tell pandas to drop the columns in this data frame itself instead of creating another data frame with this column dropped. So then we don't have to assign hotel bookings back to itself to get the new data frame, it'll drop it in place. And then we also want to do some renamings. So we can do that using the rename function. And here we can give it a dictionary of the column that we want to change and the new name we want to give it. So for the adults column, we will change that to numadult, and we'll do something similar for children and babies as well. Now for this function, we need to specify the axis is equal to 1 so that Pandas knows that we're renaming the column and not looking for these values within the rows of the data set. And then for this one, we also want to set inPlace equal to true. So now when we print out hotel bookings, we can see that the unnamed column is gone, and then you'll also see that things are renamed to num adults and num children. So next, let's try to deal with those NaN values we saw earlier. And the first step to doing that is to see which columns have NaN values and what percentage of the rows for that column are empty or NaN. So to do that, we can use the isNull function and take a sum of the number of values that are null. And what we can do here is we can multiply it by 100 and divide it by the length of the total data frame, so that we can get a percentage of values that are null within each column. All right, so here we can see like actually quite a few columns have no null or NaN values, but we see country has like 0.4% of the values as being null, and then agent has 13% of the rows without a value, and then company, 94% of the rows don't have any value for company. And I think that's pretty much it. Oh, num children also has like 0.003 rows that have a null value. So these are the columns that we'll want to look at to see if we can either fill in the value or if we need to drop those values. Now with company, this might be the easiest one to deal with since 94% of the rows don't have a value for company. That's one we can probably drop out because it looks like that's not really giving any valuable information. So the next one we can look at is agent to see if that's one that maybe we can fill in based on the other column values. For this first, let's just see what the unique values of the agent column are, just so we can see how many values there are, because if there's fewer values, it might be easier to fill in. So the unique function will give us all the unique values. Okay, so here we can see we actually have quite a few values. Looks like they're all integers. We don't actually need them to be floats, so that's something we'll need to change later. But let's just see if we can find some similarities in the columns where the agent value is equal to 5. Okay, so these are all the rows where agent is equal to 5. So it looks like it's not like a specific hotel that agent is making reservations for. There's also not anything here that's identifying why agent 5 would be assigned to a reservation. Yeah, I'm not seeing any similarities in the rows other than it's a transient customer, but the ADR is different. These things are different. Reservation status is different. There's not any commonalities between the rows that have a specific agent value, so filling in the value based on other columns will be kind of difficult. So now we really have to choose between two options. Either we can drop all the rows where agent is NaN or null, or we can fill in the value with kind of a placeholder value. Now for this case, we don't necessarily want to drop all the rows where agent is equal to null because 13% of the rows don't have an agent value for them. So we'll be losing quite a few rows if we drop all the ones where agent isn't filled in. So what we can do instead, since agent is a numeric column, we can give it a placeholder value of -1. So to do that, we just take hotel bookings and we want to subselect the agent column, and then we'll use the fill NA method, which takes a value to replace any NA or null values within the agent column, and we want to put in place equal to true. So here we're replacing all the NA columns with -1. That's generally a strategy that's used when we have missing numeric data. Now, let's say you are working with like a stakeholder on this project. That stakeholder might have certain business rules that they're using to assign an agent to a reservation. So if that was the case, you could talk to that stakeholder to see if there's certain values you look for in other columns to assign an agent to a reservation. But since we don't have that here, just replacing all the empty values with -1 is the most straightforward way to go. Now next, let's look at the num children and the country columns. Now these ones didn't have a lot of empty values, so the chances are we can probably just drop them or maybe try to fill them in, but let's check. So for this one, we want to take the subset of the rows where the num children is NA. All right, so it looks like we're only getting 4 rows for this, and we may be able to fill this in with 0, but we don't know for sure that the value is 0 for num children, and since it's only 4 columns or 4 rows where the data is missing, probably the action we'll take here is just to drop these rows because we're not getting rid of too much data. So next up, let's look at where country is NA. So we can take the same line here and then just replace num children with country. Okay, here we have 488 rows, so quite a bit more than 4. So let's really quickly just take like a subset just so we can see country. A subset of columns just so we can see country. Okay, so we see countries missing across hotels and across like cancellation status. So since country is a string, like a categorical column, we can just replace NaN countries with unknown. So we'll go ahead and do that. For filling it with unknown, for the children column, what we'll do is we'll just drop the NaN values. So for that one, what we can do is we can use the drop NA function. And here we want to specify that we want to drop any rows where num children is NaN. And we'll set in place equal to true for this as well. I'll run this. And as a final step for that company column where 94% of the rows were empty, we'll just drop that column out of the data frame altogether. So we can do that using the drop function, specify columns to company, and in place equal to true. Right, so now when we run, we can actually come up here and we can run this NaN code again, and we should see almost all of them are zeros. None of the columns have any NaNs in them. Now that we've filled in the NaN values, the next thing we can do is look through the data types of each column to make sure that they're stored as the right data type. Like strings are stored as strings, integers are stored as integers and not floats, things like that. And I normally like to do this after filling in NaN values because if I find that a data type needs to be changed, it can't be changed if that column contains NaN values. So we do have to deal with those before changing any data types. So we can look at the data frame data types by using the dtypes attribute. So if we look through this, it looks like most things are the correct data type, like a hotel is a string and it's stored as an object. Now is canceled really only has the values of 0 or 1, so it's more of a Boolean value, but it's stored as an integer. So this is one we could maybe change to Boolean. Num children is also one we can change. It's stored as a float, but it probably should be an integer, mainly because num adults and num babies are integers, and also the number of children is a whole number value. And then is repeated guessed, we can also change that to a Boolean as well. And finally, agent, you saw those were all integers before, but it's stored as a float. We should change that to an integer as well. So to do that, we will reassign bookings to the result of the asType function. And so here we can specify a dictionary where we give the current, where we give the name of the column and then we give the new data type that we want it to be. So is canceled, we want that to be a Boolean. We want to do a similar thing for is repeated guessed. And then we also want to change num children and agent to integers. And let's reprint the dtypes again. All right, so here you can see that is canceled is now a Boolean, is repeated guessed is a Boolean, and then agent and num children are ints. All right, now that we've converted all the data types to the correct data types that we want, now let's work on grouping the different columns if they need to be grouped or binned. So one of the columns that we might want to bin is lead time. So the first thing we need to do is look at lead time to see how many unique values there are for lead time. So to do that, we'll do a unique on the lead time column. All right, so here you can see there's a bunch of different unique values. I mean, they're even cut off in the editor here. There's that many unique values. And let's say we wanted to like visualize most hotel booking reservations are falling in terms of lead time. We could visualize it like this, but let's say our stakeholder wants to see it in groups. So they want to see like how many bookings have a lead time of under 100 days or over 100 days or something like that. Well, what we can do is we can actually bin the lead time so that instead of having each individual value like this, we could have the range it falls in. So this may fall under like the 300 to 400 lead time, something like that. So to do that and to know what bins to create, first let's just look at what the high and low values of lead time are. And to do that, we can use the describe function that Pandas provides. And when we run that, we see that the minimum lead time is 0 and the maximum lead time is 737. So what we could probably do is create groups of 100. So we're going to use the pd.cut function, which will actually group the lead time column, but that function does require the bins we're using and the labels for each group. So first, let's define the bins. And since we want the groupings by each 100 days of lead time, we'll just specify the edges of the bin. So that's 0 to 100, 100 to 200, 200 to 300, and so on. And our maximum is 737, so we'll just end it at 800. And then we also want to create labels. So what that pd.cut function will actually do is it'll look at the lead time value and then it'll assign it one of the labels based on which bin it falls under. So our first bin would be 0 to 100. Our next bin would be 101 to 200, and we'll keep doing that until we get all the way up to 800. All right, so now we can actually just do pd.cut and we will assign the result to a new column. So we'll call that lead time binned, and that will be equal to pd.cut, and we'll specify the column that we want to cut, which is lead time, and then we'll specify our bins, which is this variable, and we'll specify our labels. Right. And then what we can do is we can actually print lead time and lead time binned. All right, so here you can see that if the lead time's 342, lead time binned is being assigned the 301 to 400 group. Same for 737, 701 to 800. So this makes it a little bit easier to visualize numeric data if you have a lot of different columns, depending on the type of visualization you want to do. So pd.cut is a good way to kind of reduce the number of unique values you have into groups. All right, the next cleaning technique we want to go over is how to separate the data from one column into multiple columns. So here I just printed out hotel bookings again, just so you can see the columns. And you can see the arrival date here has both the month and the year of the hotel reservation. And then arrival date, week number, and arrival day of month are in separate columns. So what we want to do here is we want to split up arrival date into one column for month and one column for year. So basically we just want to split this column on this hyphen delimiter. And to do that, we'll create a new column called arrival date month. We'll actually create two new columns, arrival date month and arrival date year. And arrival date month, what we're going to do is we're going to use the split function for strings in Python, and that is going to split each of these column values by the hyphen delimiter. So you'll get an array back where the first element is July and the second element is 2015. And it'll do that for each of these rows. So we'll take arrival date. We want to treat that as a string, and then we want to use the split method. The first argument here is the delimiter we want to split on, which is the hyphen, and then we want to put expand equals to true. And what that expand equals true does is it just tells the split function to return each portion of the split string as like its own column in a new data frame, and that just makes it a little bit easier to manipulate than if we set expand equal to false. All right, so this is going to split this string into two parts. The first part will be the month and the second part will be the year. So we want to take the first part of whatever split returns. So that's why we will take what's at index 0 for the month, and for the year, we'll just take what's at index 1, since all of these strings are month hyphen year. And so now when we do bookings.head, you'll see that there's arrival date here, but at the end, we also have the month and the year split up. And what we can actually do here so that we have these columns next to these other date columns is we can actually move the columns to this position. So to do that, what we first need to do is we have to pop the column. So that's actually the function we'll use to like get the arrival date month column. And then we'll just insert it at a different position in the hotel bookings data frame. And to do that, we'll use the insert function and we will specify the position we want it to be at. And I'm pretty sure this starts at 0. So it's 0, 1, 2, 3, and then we want it at like the 4th position. So let's do 4. And then we'll do arrival date month. And then we'll specify the column to move. And now you can see arrival date month has been moved here. And we will do the same thing for the year. All right, now we have the the month and the year. And what we can actually do is we can drop arrival date, since that's just duplicated information now. And the next thing we identified in our first look at the data were some special characters in the hotel column. So let's actually just print out the unique values of hotel so that we can see like which special characters are there for some of the rows. All right, so you can see some of them are normal, just resort hotel and city hotel, but you can see a lot of these have like 2 stars at the end, or they have like 2 stars and a new line, or like a caret symbol at the beginning. So we want to clean that up, because resort hotel and resort hotel with like these special characters, they're the same thing, and we don't want them to be treated differently. So the next thing we'll do is some string cleaning, and we can actually do this with regex. Pandas has a replace function that we can use for object columns that'll replace the regex strings with whatever you want to replace it with. So we'll take hotel bookings, and we'll take the hotel column, and we'll want to reassign it to itself. So here we'll take hotel, and then we'll do a dot replace. And the first parameter that this takes is a string that you want to replace, and you can do regex here. Or here we will define a list of special characters that we want to replace. So we want to replace any instance of an asterisk, any instance of a new line, and any instance of this caret. And we want to replace that with an empty string. And we'll put regex equals to true so that this function knows that this is a regex expression. And once we do that, we can actually print the unique values to make sure that it worked. Right, so now we can see that when we look at the unique values of the hotel column, we just see resort hotel and city hotel without any of these special strings. So that means they were replaced by this regex. Now, the last step I wanted to go over is removing duplicates in the data frame. And I specifically want to focus on cases where every column value is duplicated. So Pandas offers a duplicated function which returns whether or not each row is a duplicate or not. So to see that, we can just take hotel bookings and do a dot duplicated. So duplicated has a function called keep, and what keep specifies is whether or not you want to count the first or last occurrence of a duplicated row as the duplicated row. So if you set keep to first, it'll return that the first instance of a row is not a duplicate, but every other time you see that exact row, it'll mark that as true that that is a duplicate. That keep parameter can also be set to false, where each instance of the duplicated row is treated as a duplicated row, and this function returns true for that row. So when we just print this out, you'll see that what's returned is just a series, a Boolean series indicating whether each row is a duplicate value or not. So here you can see that rows 1 through 3 are not duplicated, but row 4 does contain a duplicated row. That means that for row number 4, there's another row in the data frame that has all the same values for the columns. So we actually want to print out those rows that are duplicated. So to do that, we're going to use the .lock indexer of the data frame, and this will print out all the duplicated rows and the actual values in those rows. All right, so here you can see rows 4 and 5, this was the duplicated one, and you can see row 5 right below it all has the exact same column values. So we don't need to keep both of these rows. We'll actually just keep the first instance of each row and drop the rest of them. We will do hotel bookings dot drop duplicates. And this actually does take a subset parameter where you can look for duplicates just within certain columns. However, if you don't specify this, it will drop duplicates where the values for all the columns are the same. And that's what we want to do here. So we won't specify subset, but we'll specify keep. And we want to keep the first instance of each row. And then we'll also do in place equals true. All right, and so now when we print this one, we should get nothing returned. All right, so now we don't have any duplicates in our data frame. All right, so those are the steps for data cleaning that I wanted to go through today using the Pandas Python library. There's a lot of other steps you can do with data cleaning, and these are kind of the general steps that you would go through for really any data set. but there may be additional steps that you need to take for your specific data set. I'll also mention that data cleaning a lot of times can be kind of subjective. Like filling in missing values, there's a lot of different ways to do that. And it really depends on why the data is missing and how much information you can collect about that missing value from the other columns. I actually have a video on the types of missing data, so if you want to watch that, you can check that out here. If you're interested in data science or data analyst tutorials, please subscribe to this channel. I plan to post a lot more of these, and if you have any ideas for a tutorial you'd like to see, let me know as well. I hope this data cleaning video was valuable to you. If you have any questions, please let me know in the comments below. Thank you so much for watching this video, and I hope to see you in the next one.